Hello and welcome. Today, we're diving into a significant achievement in artificial intelligence from Google DeepMind.
What if I told you there's an AI that can walk up to a game it has never seen before and not just learn to play it, but become a grand master, all without anyone ever telling it the rules? It sounds a little bit like science fiction, right? Well, it's the very real story of MuZero, a totally groundbreaking algorithm from DeepMind. In this explainer, we're going to break down how it works and why its really clever approach to planning is such a massive deal. So, here's the game plan for today. We're going to start with the journey that even made MuZero possible, looking back at its ancestors, AlphaGo and AlphaZero. Then we'll get into the weeds with something called the planning problem, this huge roadblock that AI researchers were up against. After that, we'll see MuZero's incredibly elegant solution, and of course, look at the proof. How did it actually perform? Finally, we'll zoom out to see the bigger picture and what this all means for AI and, well, for us. All right, to really get why MuZero is such a leap forward, we have to look at where it came from. And we're not talking about ancient history here. This all happened in just 4 years. It was this rapid-fire evolution of mastery, where each step was amazing, but also revealed an even tougher puzzle to solve. It really kicked off in 2016. AlphaGo just stunned everyone by beating the world's best Go player. Then, just 2 years later, AlphaZero took it to another level. It taught itself to play Go, chess, and shogi not just well, but at a superhuman level. But, and this is the key, both of them had a crutch. They needed the rulebook. They had to be told exactly how the game worked. The jump to MuZero in 2020 was all about finally and completely throwing that rulebook away. And that challenge, figuring out how to act when you don't know the rules, that gets us right to the heart of a major dilemma in AI. It's known as the planning problem. For years, it kind of forced researchers into one of two camps. And honestly, neither one was perfect. So on one side, you had what's called look-ahead search. This was the engine inside AlphaZero. You can think of it like a genius. With a perfect, high-definition map of a city, it can find the best route, no problem. But drop it in a new city with no map, it's completely lost. It has to have the rules. Now, on the other side, you had model-based systems. These guys tried to build their own map from scratch. But the real world is incredibly complex. They would get totally bogged down trying to model every single tiny, irrelevant detail. It's like trying to map the path of every single raindrop in a storm. They just couldn't handle the complexity. So, you see the problem, right? This was the million-dollar question. How do you create an AI that can plan as brilliantly as AlphaZero, but can also learn a brand new world from scratch without getting completely overwhelmed by all the noise? How do you plan effectively when you don't even know the rules? And the answer, the genius at the core of MuZero, is just so beautifully simple. It's this idea that instead of trying to model everything or needing a perfect model handed to you, you just focus on what's important. It basically learns to ask itself, what is the absolute bare minimum I need to know to make the best possible decision right now? And that's what makes MuZero a real game changer. Yes, it learns a model of its world, but it's a super selective one. It learns to predict only the things that are absolutely crucial for planning a winning strategy, and it just treats everything else as background noise. It tunes out the fluff. And what are those crucial things it focuses on? You're gonna love this. It's just 3 simple questions. That's it. First, the value. Big picture, how good is the spot I'm in right now? Second, the policy. Okay, what's the single smartest move I can make from here? And third, the reward. Looking back, did that last move I made actually help me? It doesn't need to know what a pawn is, what a rook does, or why a ghost stone is black or white. It just learns to predict these 3 things. The DeepMind team came up with the perfect analogy for this, and I love it. They said, knowing an umbrella will keep you dry is more useful to know than modeling the pattern of raindrops in the air. And that is exactly what MuZero does. It doesn't waste time modeling every single raindrop in the environment. It just learns the umbrella, the thing that actually matters for winning. It's such a powerful and efficient way of thinking about intelligence. Okay, so it's a really elegant theory. It sounds great on paper. But the real question, as always, is, does it actually work? How did MuZero do when they actually put it to the test against other top AIs and human benchmarks? Well, let's take a look. This is the classic Atari benchmark, where a score of 100% means you're as good as a human player. As you can see, previous state-of-the-art AIs were already way beyond human level. But then, look at MuZero. It didn't just beat them, it set a whole new record. This was the ultimate proof that its approach, ignoring the noise and focusing only on what matters for planning, flat out works. But what about the classic games? Could it still hang in the world of pure strategy where the rules are known? The answer was a resounding yes. In Go, chess, and shogi, MuZero performed at the same superhuman level as AlphaZero. And this was so important. It proved that this new approach wasn't some kind of compromise. It was a powerful, general-purpose planning machine that could dominate, whether it had the rulebook or not. And this chart, this really shows you the power of MuZero's planning ability. It's showing its skill in Go based on how much thinking time it gets for each move. Give it just 1/10 of a second, and it plays like a really strong amateur. But let it think for 50 seconds, and its performance just skyrockets. We're talking an increase of over 1,000 ELO points. That is like going from a talented club player to the undisputed world champion. So its planning isn't just effective, it's incredibly scalable. So it's clear MuZero is a huge step forward in teaching AI how to plan. But these kinds of breakthroughs never happen in a bubble. To really understand what it means, we need to kind of zoom out and see where it fits in the wider world of AI research. For instance, while MuZero is busy mastering logic and strategy, there's this whole other branch of AI that's focused on pure creativity. We're talking about generative models that can take a simple text prompt and create a breathtaking image with Imagen, or even compose original music with Lyria and generate high-def video with Veo. It's all part of the same family of research. But maybe the most powerful application is in science. The same core ideas of modeling incredibly complex systems are at work here. You have AlphaFold, which basically solved the 50-year-old grand challenge of protein folding. You have Genome discovering millions of new stable materials. You even have things like alpha geometry solving insanely difficult math problems. In a way, each one of these is like a MuZero for its own scientific field. And that's really the point. This progress just keeps building on itself. Every single breakthrough from AlphaGo to AlphaZero to MuZero becomes a critical stepping stone for whatever comes next. They've directly laid the foundation for today's most powerful AI systems, like the Gemini family of models, which bring all of these different abilities together. So, we've seen AI master games, we've seen it create art, we've seen it accelerate science. It's an absolutely incredible display of what technology can do. But it all really funnels down to one single, all-important question. What is this all for? What's the mission? What's the point of it all? Well, the official mission statement is pretty clear: to build AI responsibly to benefit humanity. The core idea is that all of this amazing progress in planning, in creativity, in science, it has to be aimed at solving real-world challenges and making a tangible, positive impact on all of our lives. And that brings us full circle. We just spent this whole explainer talking about how an AI learned to plan in a world where it didn't know the rules. So the final question, it isn't really for the AI. It's for us. As these systems get more and more capable, how should we plan for the world that we are building right alongside them? Thanks for watching.
Don't forget, like and share to spread AI knowledge.